Hello my dear students, now we are heading towards the experiment number 5, that is the power measurement. Okay, so how we can measure the power? In the objectives we have to learn the different ways of measuring power and learn how to evaluate the accuracy of the power measurements. The term power is defined as the time rate of transferring or transforming energy. So in microwave energy we have to calculate the power measurement. There are a lot of average powers and a lot of powers. So power peak power, that is divided by the duty cycle of the average power. So it is quite bit similar. It's a very simple type of experiment. To use it connect the thermocouple mount to the controlled gain amplifier of the RF shielding, and there is a meter. That is the total construction of the thermocouple power meter. That is the total thermocouple power meter. In microwave frequency generations, the heat has been generated through the frequency. That is because we are just dealing with the high frequency, and high frequency means high power. So the thermocouple will take the frequency part, the temperature of the frequency, and get back to the controlled gain amplifier and the RF shielding side, and the controlled gain amplifier will show the meter that how much gain or power that it feels on the thermocouple mount. There are two 5.6 volt batteries to run this meter. Okay, the experimental procedure, that is direct measurement. How do you measure directly? First of all, connect the power supply with gun oscillator and variable attenuator with waveguide to coaxial adapter. There is a thermocouple mount to find out the power meter. Just adjust and take the reading of the meter. Without the signal activated, set the range to somehow x1 milliwatt or 2 milliwatt or 3 milliwatt, and adjust the meter to 0. Turn the gun oscillator, adjust the variable attenuator to 3 decibel, and read the power meter and record the reading. Now the power measurement using a directional coupler. So there is a power supply through the gun oscillator, variable attenuator. Just use a directional coupler in that particular point. In that particular point, if you want to find out with the directional coupler, there is a directional coupler that has been used here. The collinear axis should have to be connected to the match termination, and the other part, what can I say? In thermocouple there are two there are two way of propagation. One is the collinear axis, one is the perpendicular axis. Okay, so the perpendicular axis should have to be connected to the waveguide to coaxial adapter. Then the thermocouple mount and the power meter should have to be connected in that particular session. Now after setting this, do not alter setting on the power supply. That means you should just take the same thing and take the reading of the power meter as what can I say, as before in the A section. Measurement of conjugate and Z naught power. So that is a very complicated setup. Okay, to find out the conjugate and the Z naught power. That means the characteristics impedance power. So connect power supply with the gun oscillator in the variable attenuator, and connect the input section of the directional, not input section, the output section of the directional coupler. That means the second collinear part, the output part of the collinear axis, and the another axis should have to be connected to the PIN diode modulator, crystal oscillator, the SWR indicator. That means the output section, crystal detector. Just alter the directional coupler, and the input part should have to be connected to the slide screw tuner, waveguide to coaxial adapter, thermocouple mount and power meter, and then find out it. That means just alter the directional coupler and just add another two crystal detector and power meter section to find out that. Set the variable attenuator to 3 decibel. Modulate the output of the directional coupler with square wave of 1000 pps. Adjust the pulse frequency to maximize the SWR meter, Z naught power. Do not change the signal power level. Adjust the slide screw tuner for the maximum indication on the SWR meter. Use the most sensitive range of the SWR meter. Record the reading on the power meter. conjugate power, adjust the slide screw tuner to get the maximum indication on the power meter, record the reading. That is the setup equipment. So setup measuring the output power of a modulated signal. That means if it is a modulated signal, how can you find out the power from that? Simple. Modulated signal means the setup requirements are quite similar to the experiment number 2. Power supply, Gun oscillator, PN diode with a square wave generator, variable attenuator, then waveguide to coaxial adapter, then go through to the thermocouple mount, and you will find out the power meter out of that. And the variable attenuator should have to be on 10 decibel. Adjust the output of the pulse generator to 0 volt peak to peak, offset the output by +0.5 volt DC, observe the power meter and record the meter reading. Adjust the output of the pulse to 2 volt peak to peak, set the offset to 0 volt, record the power meter reading. Okay, then replace the thermocouple mount and the power meter with crystal detector. Connect oscilloscope to the crystal detector. Adjust the vertical position of the scope to align the top of the square wave to the zero level to the screen. The reason for this adjustment is that the output of the crystal detector is negative, therefore the power at the top of the pulse is actually less than the power at the bottom of the pulse. Reduce the attenuation of the attenuator until the bottom of the square wave lines up the zero level, and scope, record the change in attenuation. So there are a lot of scales in it. You just follow this. I am not going through to the next part of that for considering mismatch. I just need this attenuation position versus frequency meter, power meter reading. Okay.